A very good morning and welcome back to my channel, which is teachercool. So till now we were talking about the basics, the particles, antiparticles, matter, antimatter, and then we talked about the beta decay and the W bosons, etc. Now this is the last part of this chapter, which are the weak nuclear forces. We said we will talk about beta decay, and somewhere we talked about beta decay also in our previous video, but this time we will get to know what actually is my beta decay and what is electron capture and what are the weak nuclear forces. So let's start. See, till now we have discussed about the electromagnetic forces which are between the charged particles. Then we talked about the strong nuclear forces which exist inside the nucleus and is strong enough to bind all the nucleons together, overcoming the electrostatic repulsion between the charged particles, which are protons, and also overcoming the electrostatic attractive forces between the protons and the outside the nucleus electrons. But when I'm talking about the beta decay, we say that the strong nuclear forces we were talking about is strong enough to bind the nucleons together, very right, but these forces cannot cause the beta decay. Now, what is beta decay is basically when a neutron gets converted to proton in a neutron rich nucleus, or when a proton gets converted to a neutron in a proton rich nucleus. So, the strong nuclear forces are strong enough to bind these nucleons, but these strong nuclear forces cannot cause the beta decay, right? So the next is electromagnetic forces, but we know that the neutron जो particle है, it is neutral, it is chargeless. So we say कि electromagnetic force also will fail in causing the beta decay because neutron is neutral particle. So we say that there must be some new force, or there must be some new interactions, interactive forces जो इस काम को कर रही हैं, which is causing the beta decay. But जो ये new forces I am talking about, ये इतनी strong नहीं होनी चाहिए. They should not be strong enough that they interfere with the stability of the nucleons. That means these new forces should be weaker than the strong nuclear forces so that my nucleus remains stable. Hence we say the name, which are weak nuclear forces, because these are weaker than strong nuclear forces and inside the nucleus only. And also we say that in both the beta positive and beta negative decay, a new particle and a new antiparticle, दोनों के केस में बीटा पॉजिटिव में भी और बीटा नेगेटिव में अलग अलग एक न्यू पार्टिकल और एक न्यू एंटीपार्टिकल जो है वो क्रिएट होते हैं. बट इन अ सिंगल प्रोसेस दीज आर नॉट द करस्पॉन्डिंग पार्टिकल एंटीपार्टिकल पेयर्स. जैसे when I'm talking about this beta negative decay, right? So when a neutron interacts with a neutrino, it results in a proton and a beta negative decay, right? Now this is new particle, then here it is antineutrino reacting with the proton, resulting in a neutron and a beta positive. See, this is one reaction, this is another reaction. Beta positive and beta negative are corresponding pair, whereas neutrino and antineutrino are corresponding pair, but these are being created in different equations with different decays. Now, what is W here? See, we talked about that whenever interaction is taking place, there is some carrier which is transferring the momentum or which is transferring the effect of the force from one particle to another particle. And we said these are my W boson and my photon, right? So this is the same W boson which we just talked about in our previous video. We say this W boson here will carry my charge and redistribute it. And what are the basic properties of this W boson are? These are carriers of force named as W bosons. They have non-zero mass. When we talked about photons or virtual photons, they were chargeless particles. Their rest mass was also zero, but here they are non-zero rest mass particles. They are very short range of the order of 0.001 femtometer, and also they can be charged, right? When we talked about photons or virtual photons, they were massless and the chargeless particles, but in case of W, we have non-zero rest masses plus short range plus they can be charged also, W positive and W negative. Now, if I draw the diagram, we say when a neutron interacts with the neutrino, W negative boson के through the interaction is being carried over and they result in a proton and a beta negative decay. Just to remember कि आपके क्या products बनेंगे. See, overall here there are no charges, neutral है. Here it is negative and a positive charge over a proton, so the total charge over here is again 0. Right? Similarly, when a proton is interacting with the antineutrino through the W positive boson, we get the result as neutron plus beta positive. Here it is proton, so overall charge is positive. Again here the overall charge is positive. Neutrino, antineutrino and neutron are neutral particles. These equations are known as my beta decay. The basic rule, if you want to ask why are we including the W boson over here, is because when we say a proton is getting converted to neutron, because here we are talking about neutron interacting with neutrino. Neutrino and antineutrino are the particles which you can say rarely interact. If I tell you the analogy, I'll say billions of neutrinos and antineutrinos are passing through Earth from the space, but it hardly affects us because they do not wish to interact, right? So it's a 1 in a billion, you can say, reaction taking place. So this will be a better analogy, or it will be a better way to predict the beta positive and beta negative decays, that neutron is getting converted to proton and the side result is W negative boson, which will further break down or decays into beta negative and antineutrino. Similarly, proton will decay to neutron, releasing W positive boson and hence the beta positive and neutrino. Now again, if we look at the charges, right? So here this was neutral, right? तो न्यूट्रल से रिजल्ट जो दो हमारे डिवाइड हुए हैं, दैट शुड आल्सो कम आउट टू बी न्यूट्रल. सो प्रोटॉन इज पॉजिटिव, W नेगेटिव इज नेगेटिव, सो ओवरऑल चार्ज इज नेगेटिव, ओ सॉरी 0. देन सिंस अब इतनी सी रिएक्शन को देखते हैं. नाउ सिंस इट इज नेगेटिव, so its decay product should have a overall of negative charge, so W negative will decay to beta negative with antineutrino, right? Now same way, proton is positive and here it's going 0, so that means this positive charge has gone to this side. Again W positive will decay to beta positive and a neutrino. Now if you ask, ma'am, how to remember when it will be a neutrino or antineutrino? The trick is that whenever W boson will decay, there will always be a new particle antiparticle pair, right? So I say that beta negative is a particle whereas antineutrino is a antiparticle. Beta positive is antiparticle, neutrino is particle. They are not the corresponding pair, but it's a particle antiparticle. So beta negative will decay to beta negative plus antineutrino. W positive will decay to beta positive and neutrino. Now I am saying that these two Feynman diagrams are same, but you will ask, ma'am, here it was, अगर यहाँ से इसे इसको flip करके देखें तो it is neutron getting converted to proton and then it is W negative, which is same till here, but after that this is beta negative, same, but this neutrino is getting converted to antineutrino. Why? So इसका explanation is, here it was going towards the W boson and here it is coming out of the W boson. So this way you can remember it, and same goes for this thing. This was going towards W positive, this is going away, right? Now next is electron capture. This was your beta decay, where if my nucleus is rich in protons, proton will convert it to neutron. If it is neutron rich nucleus, it will get converted to proton when instigated. Next is electron capture. A proton in a proton rich nucleus. Earlier it was a proton rich nucleus, and internally only this proton is getting converted to neutron, right? But here I am telling it is a electron capture, as the name suggests. Now this proton rich nucleus will capture an electron from somewhere, from where a proton in a proton rich nucleus turns into a neutron as a result of interaction through weak forces with an inner shell electron. जो न्यूक्लियस के पास वाली शेल होगी उसी का जो क्लोजेस्ट इलेक्ट्रॉन होगा फ्रॉम आउटसाइड द न्यूक्लियस, वो जो प्रोटॉन रिच न्यूक्लियस है उस इलेक्ट्रॉन को अपने अंदर कैप्चर कर लेगा, एंड एज अ रिजल्ट इट विल turn into a neutron, right? So this electron here is being captured and the resulting interaction is taking place. Now same happens agar, see, similar is happening when a proton is getting converted to neutron internally, or when it is capturing an electron from the outer innermost shell. And also if you say, if you have a proton emission and an electron emission with sufficient energy and they are made to collide head on, the same result will be observed. So this will remain the same. Last is जो आप कह सकते हैं, the summary of this whole chapter is that whenever we are talking about interactions, weak forces, strong forces or electromagnetic forces, there is always a force carrier which is transferring the momentum or the charge or any quantity which is resulting in the interactions, and these carriers are known as the force carriers, which are mainly the photon, the virtual photons, and the W bosons, W positive and W negative. And these force carriers are mainly the force carriers in weak interactions, because all these interactions are weak because they cannot interfere with the strong nuclear forces to avoid interfering with the stability of the nucleus, and also the electromagnetic interactions. So with this we finish this chapter of particles, antiparticles and weak nuclear forces, etc. And very soon we'll be back with the next chapter, which is the quarks and the leptons, which is very interesting if understood, and it's like a family tree. The basic analogy will be a family tree that will start from the grandfather, and then we'll divide the family into the parental generation, and then we go to the children generation, and this way we'll classify all the fundamental particles, their properties, their behaviors, and it's very interesting. But if you do not get the analogy, it gets quite confusing also. So we'll try not to make it very boring or confusing. We'll try to make it very interesting and very easy also. But till then, do like, share and share and subscribe to my channel, which is Teacher Cool. And if you have doubt in this session or in this lecture, do let me know in my comment section, right? I'll get back to your doubts. Thank you so much. Stay tuned.